Alright, so we're going to work on simplifying complex fractions. So hopefully you've gone through the activity and got a little understanding on looking for the least common multiple to solve these guys. Well, what this one to start out with, this is a pretty complex fraction altogether. So we're going to work through this. To start out with this problem here, I want to look at this fraction right here and get that set up first and work on this. So let's go ahead and just write this out again and get this simplified itself before we work on the overall big fraction. Okay, so now we need to get rid of this little fraction underneath the big fraction here. So as you should see, this 2 is over a 1. But we need to have a common denominator here on this bottom part here to add these top two numerators. So what we're missing over here on this 2 is an x plus 1. So we're going to take x plus 1 over x plus 1. And we're going to multiply that by 2 over 1. So all this will be times 2 over 1. And then we're still going to have plus 1 over x plus 1. Okay? So therefore, we can get the common denominator here. So this will give us then 1 all over still. We're going to have now 2 times x plus 1 plus 1 for our numerators, and all of that is going to be over x plus 1. So we just need to simplify this a little bit further, and we're going to take that and still got a 1 on top, and we're going to have 2x plus 2 times 1 is 2, and a plus 1. Erase that there, make this a little bit easier to read, plus 1. And all that is still over x plus 1. Now hopefully you've seen in the activity as well, when you have a fraction with the fraction for the denominator, this is, if you just flip this denominator, it'll actually just make this a fraction it needs to be. So this is equal to x plus 1 over 2x, and then we have 2 plus 1 gives us 3. Okay. So now that is the blue part right here. So now if we were to rewrite this equation here, that's good. So if we were to do that, in order to say, same thing as saying 1 plus 2 over x all over, and this would be 3 plus, and then we've got x plus 1 over 2x plus 3. Alright, so now if we follow the rules of what it looked like the activity that I gave you guys, you will see the easiest thing to do is take your least common multiple and multiply it times the numerator and denominator. Well, in this case, our least common multiple is going to be, we have an x for the denominator here and a 2x plus 3. So if we just multiply those together and multiply that times the numerator and the denominator, it should simplify this quite a bit. So we're going to say multiply, and we're going to say x times 2x plus 3 all over again x times 2x plus 3. Okay. And then we just need to multiply this out. So let's see here. We do a different color here since we did that as far as our least count multiple. So this is going to equal 1 times all of this here is just going to give us x times 2x plus 3. And then we're going to have, make that parentheses a little bit better, plus, now we have 2 times x plus, well, times 2x plus 3, sorry, 2x plus 3. And all of that is over x. Okay. On the denominator, 3 times x times 2x plus 3, so 3 times x times 2x plus 3. And then plus, in this case, now we've got x plus 1 times x times 2x plus 3. And all of that is over 2x plus 3. So now you should be able to see some things that are going to cancel out here for us. There should be quite a few things that kind of cancel out. So on this top, on the numerator, our x's should cancel out. These guys should go away. And on the denominator, our 2x plus 3 should go away. So therefore, we would just be left with that x plus 1 times x. So those guys go away. Alright, let me draw a little bracket here so we know we're not getting all this confused. Okay, that was our first little part there. So now that we've got that, let's go back to our purple color here so we can go with what we're doing. And again, let's just rewrite this. Since we've canceled those things out, let's write this without those values in there. So we should simply have x times 2x plus 3 plus 2 times 2x plus 3. All this is over 3x times 2x plus 3 plus, and then we have x plus 1 times x. Alright, so now we just need to simplify this a little bit further. Alright, so let's just distribute the x through this top part, same with the 2's and so forth, and going forward with this. So we'll do this in a different color here. We'll go with, let's go with a green. Alright, so let's say we have, on the top there, we should have 2x squared plus 3x plus 4x plus 6. And on the bottom, you distribute those, we should get a 6x squared plus 3 times 3 is 9x. And then over here, we should have x times x is x squared. And then just 1 times x is plus an x. So now this should give us, we're just going to combine like terms. So on top we have 2x squared plus, there's no other x squareds in there, so now we just add the x's. We have 3 plus 4, this should give us 7x plus 6. And for denominator, we should get x squared as what we got to start with. We have a 6x squared and just a 1x squared, so 6 plus 1 is 7x squared. And then we have 9x plus 1x, so this should give us plus 10x. Alright. And with that, that is as simplified as we can get it. So the overall answer for the simplified complex fraction of this big problem we started out with over there is just 2x squared plus 7x plus 6 all divided by 7x squared plus 10x. Now, you can check this out by putting in a number, initially putting a number in for x up here in the top equation, and down here the same thing for the bottom equation to make sure it works. Again, the only other thing you need to realize there, if you're to do that, because our least common multiple was x and 2x plus 3, if you're to set both those equal to 0, so if we have our least common multiples, right, and we had, let's write it out again, x and 2x plus 3, well, if you set each one of those to 0, x, 0, well, you can't solve anymore with that, right? So x cannot equal 0, otherwise this will not work. If you put a 0 in here, you see we'd have a 0 for a denominator right off the start here, and therefore it would be undefined. Also, if you took 2x plus 3 and made it equal 0, and you solve for x, you would get x equals negative 3/2. So x cannot equal negative 3/2, otherwise that would give you would not be able to solve the actual fraction, complex fraction, with using negative 3/2. So those two values you can't use. But any other number you want to use, you can use. So if you're to put the number 2 in for x here, and solve it for this first equation, and you should get the same answer as you would for the bottom equation, like you did in the activity as well. Alright, so let's do another little example here. Alright, so on this one, we've got a little bit simpler setup for it, right? Now we just kind of follow our rules that we went through in the activity, and which part we went on our second step of dealing with the first problem. We just need to find our least common multiple. So in this case, since there's no fraction up top, there's just a fraction at the bottom, we can simply say it's just x plus 2. Alright, so to get rid of this x plus 2 fraction at the bottom, our least common multiple is simply just be x plus 2 over x plus 2. So let's go ahead and multiply that out. X plus 2 on top, and an x plus 2 for a denominator. And if we do that, let's see what we get. So we have 5 times x plus 2 on the numerator. On your denominator, you have 1 times x plus 2, so that would just give us an x plus 2. Alright, I'll put that in parentheses just so we know that was 1 times that. Minus, in this case, we'll have 2 times x plus 2, and that is all over x plus 2. Now you can see that this x plus 2 on this bottom fraction will cancel out. This guy goes away. So then we're left with a little bit more simplified fraction, almost there. So before I distribute through, we'll leave it as still as 5 times x plus 2. And then that'll be over. On the bottom we have x plus 2 minus 2. And so now we just need to deal with distributing that 5 monomial up top and then just combining like terms. So now if we take a 5 distributed in here, we should get 5x plus 10. And on the bottom we have x, and then 2 plus 2 minus 2 gives us 0. So we should, for a simplified fraction, for this complex fraction to start with, we should get 5x plus 10 over x. And with that, you can again check it out like I said. But what number can you not use? Well, hopefully you see that you cannot use a negative 2, because we said our least common multiple was just x plus 2. Well, so if you took x plus 2 equals 0, and you just solve for x, x will give you negative 2. So in other words, if you had a negative 2 for your x, it would not work because you get 0 on this bottom denominator right here, right? So x cannot equal negative 2. So if you put any other number in there besides negative 2, you would get the same value if you stuck that x value in this problem or in this one. Either one would work out. Alright? We'll do one more. So this last one is pretty similar to kind of how we dealt with the first one, right? So let's go ahead and we're going to take this fraction and we're going to simplify it first. So again, we have 1 over 3 plus 1 over x minus 1. Well, again, this 3 is over a 1. We need to get the denominator to be an x minus 1. So we're going to multiply times x minus 1 on that. So for this one, it's going to be 1 over, in this case, we're going to take x minus 1 over x minus 1. We're going to multiply that by 3 over 1 plus 1 over x minus 1. With that, that'll give us a common denominator on the bottom, so we should get 3 times x minus 1 plus 1 all over x minus 1. Since they have the common denominator now, we can just add the numerators. Now let's just go ahead and distribute that 3 into the monomial and combine like terms. So we should go 1 over, in this case you get 3x minus 3 plus 1. Okay? And then on the bottom we still just have x minus 1. And now let's combine like terms. So we should get 1 over, in this case we should have 3x, and then negative 3 plus 1 is negative 2 over x minus 1. And that little trick like we showed you on the first problem, if you have a fraction for the denominator, and especially if you have a 1 up top, if you just think of it as you're just flipping this guy, so you have x minus 1 over 3x minus 2. So now let's rewrite that problem up there. So you should have 6 over 2 plus x minus 1 divided by 3x minus 2. Now we just need to do our setup like we would do in the other problems, not least common multiple. For the least common multiple, you should see the only fraction or denominator we have that we need to get rid of is this 3x minus 2. So our least common multiple is 3x minus 2. And let's see what x cannot equal just to start out with it. If we took 3x minus 2 and equals 0, then you would get your x should equal 2 over 3, which we do not want x to equal that, because if it does, then this would not work out at all. So let's move on with what we need to do next here. So let's see, well first off, we'll multiply a common multiplier. So we're going to take 3x minus 2 over 3x minus 2 and multiply that. And we're going to see what we get. So we're going to take a 6 and multiply it times that. Alright, so let's get our color here. So we're going to take 6 times 3 should give us 18x, and then minus 6 times 2 should give us 12. And on the bottom, for the denominator, we should get 2 times 3x minus 2 plus x minus 1 times 3x minus 2 all over 3x minus 2. Okay? Draw this on a little bit. Now you should see that these guys, this 3x minus 2, cancels out. So now, let's combine, distribute, combine like terms. So on top, we still should have 18x minus 12. And on the bottom, so I have 2 times 3x minus 2 plus x minus 1. Okay? So now, we're going to simply say we have 18x minus 12 on the numerator still. The denominator, we should have distribute that 2 into the monomials, so we have 2 times 3, which is 6x minus 2 times negative 2 is negative 4. And then we still have plus x minus 1. We should move those parentheses because it's not needed. It's just a line in front of it. Okay. Make my line not as long here. There we go. And then now let's just combine like terms on the bottom to get our final answer. So 18x minus 12 all over. Now we have 6x plus x. This should give us 7x. And then we have negative 4 minus 1. So we should get negative 5. And that is our simplified fraction from that complex fraction right there. So 18x minus 12 divided by 7x minus 5. Again, you can plug in any number except for a 2 over 3 for your x value, and you will get the same answer if you plug it into our initial problem we started out with or into our simplified fraction that we got down here at the bottom. Alright guys, so we learned a little bit something today, and I'll see you next time.